So you're not only looking for distance, you're looking for that one that has the right angle. The reason that one's special is because it's the shortest distance from a point to a line as long as it's perpendicular. How do I know what segment is perpendicular in this image? What are you looking for? The 90-degree angle. So this little segment right here is going to be the shortest distance from point C to this line. All right. So if you look very closely, this is a right triangle, right? And if I look at this right triangle, we kind of reviewed right triangles at the beginning of the year. We've used it a couple of times here and there. Do you remember what that side is called, the one across the 90 degrees? What do we for the hypotenuse? What do we know about the hypotenuse other than it being across the 90 degrees? It should be what to the triangle? The longest side. It's the longest side. So if this is the longest side, can we then say that this has to be longer? C to A must be longer than C to whatever this point is. Yeah. So the shortest distance, and that's going to be your first question. First questions to give me on the homework. Very simple. What's the shortest distance? You're going to pick whatever the point is to the line, that segment that's creating that 90 degrees. So that perpendicular segment is what you're going to select. Hopefully we all select the right name and then the right measurement there. All right. Also, the other theorem we have is that through any point, in comparison to a point to a line, through that point, there only exists one line. Only one line that's perpendicular to your line. So you can't have multiple lines going through that point. If that line going through that point has to be perpendicular to the given line, there can only be one line that does that. There can't be multiple. If you slide it over for just a bit and you start bringing it down so it's not the same line, well, you've already changed the degrees. It's now going to be more than 90 or less than 90, but it's no longer going to be 90 degrees, okay? That's more beneficial to a proof, not for our homework, okay? So what I'm going to have y'all do is we're going to graph a line, then we're going to find the shortest distance from that line to a point. So here it says line L contains these 2 points. The first thing I'm going to have y'all do, and you're going to do the same thing on the homework, is just graph this line. So graph negative 5, 3. So negative 5, 3. Negative 5, 1, 2, 3 would be about right there. Okay, you're going to also graph 4, negative 6. So 1, 2, 3, 4, 5, 6. And then with your ruler, mine might be off, so with your ruler, make a straight line. Let's see if it works this time. If you don't have one, I still have them up here if you want to come by and pick one up. Okay. So this is going to be line, what's the line called? Line L? All right, so at the arrows, one of the arrows, just put the cursive L. That's line L. All right, we're going to find the shortest distance from this line to point 2, 4. So I'm going to go ahead and graph 2, 4, and I'm going to call that point P. So remember that anytime you're finding the perpendicular distance, there can only be one segment connecting it. This is going to be the shortest distance. So the first question is, what's the slope of the line given? So you can find the slope of this line doing 2 things. You can do rise over run, because we practiced doing that. You could also just use the formula, right? The formula just for slope. I'm going to go with the slope formula just in case my line's off, because I did have to do it on this iPad. What would my equation be if I plugged in my points, these 2 points here, into my slope formula? Remember, slope formula is y2 minus y1 over x2 minus x1. What would we get? Negative 6 minus 3 over 4 minus negative 5. Double negatives is going to make that a positive. Good. What's negative 6 minus 3? Negative 9. And what's 4 plus 5? 9. 9 divided by 9 is negative 1. So technically, even though it's negative 1, it's negative 1 over 1, right? All right. So what would be the perpendicular slope to it? 1 over 1, right? Which technically is just what? 1. Your ones, just so you know, your ones are the only exception when it comes to that opposite reciprocal. The opposite reciprocal is there, but the ones are the only ones where you can say if one's positive, one's negative. All your other slopes, if you're looking at perpendicular slopes, they're either both fractions or at least one is going to be a fraction once it's simplified, right? Because you can have 2 over 1 and negative 1 over 2, but this one can be written as 2 and then compared to a half. So see, these are perpendicular. This is in fraction form, but that one doesn't necessarily have to be a fraction. That one can be a whole number. All your numbers are going to either look like this or like this, except the one. The one's the only one that's going to be a whole number on both, okay, after you reduce it. All right, so it says graph and label point P, which we already did. Apply the perpendicular slope from P to the line. All right, so my perpendicular slope was 1. So if I write this as a fraction, it's 1 over 1. What directions am I going when I'm graphing this? Up and to the right. Once you have that one down, decide the opposite directions. What would the opposite directions be? Down to the left. And the reason I have you write the opposite right away is because you never know which one you're going to use. So if I try using the purple arrows first, if I go up to the right, up 1 over 1, well, am I going to get to my point or to my line? No, I'm going away from my line. So you don't want to use the arrows going up to the right. You want to the one going down to the left. So from P, I'm going to go down 1 over 1 until I hit my line. Down 1 over 1, down 1 over 1, and then down 1 over 1. It should hit here at the negative 2. Okay, so this is the shortest distance. So with your ruler, just connect those 2 points, just those 2 points. Okay, to solve it, y'all can use one of 2 methods. I don't care which one you pick. I'm going to give you both formulas the day of the test. You just decide the one you want to use. So from here, the one you already know, the one you are very comfortable with is Pythagorean theorem. I'm going to do that one second. The other one you did study. We haven't seen it in a while, but that's the distance formula. And that one is x2 minus x1 squared plus y2 minus y1 squared. Now you're finding the distance between these 2 points. That means you have to use that point at P and the point here that you found on the line. Those are the 2 points you're going to use. All right, so where is P located at? It's located at at 2, 4. So I'm going to just write that here, and then I'll go on. This is at 2, 4. Where's the other point at? The other blue one, this one right here. Negative 2, 0. All right, so using those points, I'm going to plug it into the distance formula. You can see a little better. Okay, so if I plug, using these numbers in red, I'm going to plug this into the distance formula. If it helps you, go through, label x1, y1, x2, y2. All right, so what would I plug into this formula? How would I plug in my numbers? I would do the square root of what? What's your x2? Negative 2 minus 2, close it, squared, plus, what's your y2? 0 minus 4 squared. All right, this was back in chapter 1. Right, it's been a while. What's negative 2 minus 2? Negative 4. What is 0 minus 4? Negative 4. Do y'all remember what I said back in chapter 1 about the next step? After you do this step, what should always be true about the next step? Anyway, it's always positive, because a negative by a negative is always positive, and that's what you're doing. You're squaring. You're multiplying it to itself only 2 times. So what's negative 4 squared? 16. Negative 4 squared again we said was 16. This is the square root of 32. And then you can enter it in the calculator if you wish. Right, second, the baby blue, x squared, and then enter 32. Rounding it to the 10th place, this would be about 5 point, what do y'all get? 7? 6.5? So if it's 5.65, would it round to 5.7? Okay, 5.7. That would be your answer. Okay, so that's using distance formula. The part you need to be careful with is that when you're using your points, you have to use the 2 endpoints that make that perpendicular segment there. Okay, let me show you the other way. The other way, I think it's easier, but for some reason, making the triangles the hardest part for my students. I don't know why. because they want to make a triangle going a different way. So we're going to make a right triangle. And the way I make it is I use these two endpoints, and I'm just going to rise and run it till they meet. So I'm going to rise, and I'm going to run until they meet, and there I made a right triangle. Do y'all agree that's a right triangle? Okay, you can make a little right angle if you want there. There's your right angle. Wrong pen, sorry. There it goes. Right there. Okay. All right, so what are we looking for? We're looking for the distance between those two blue points. So is that your A, your B, or your C? That is your C. The other ones are A and B. They're interchangeable. I don't care which one you make what. All right, we're going to count the units. How long is this side here? 4. They're four squares, right? 1, 2, 3, 4. So you're going to put 4 there. How long is the side? 4. All right, so if I'm using Pythagorean theorem, I'm going to do a squared plus b squared equals c squared. I cannot stress that the most important letter here is the C. If you don't get that right, the whole thing's wrong automatically. So C is the one missing. A and B can be interchanged. 4 squared plus 4 squared. We already did the squares. What are they? 16 plus 16. And we already decided 16 plus 16 is 32. So C is the square root of 32. And that's exactly what we had with the distance formula. Okay? But for some reason, the hardest part is making the triangle. Once you've made the triangle, you're fine. It's just making the triangle. Kids usually try to bring this side directly down here. Okay? The only problem with that is you can't count those units. Okay, now, I see why they do though, because what did we say? This is the shortest distance, right? And this is called what type of distance? Do you remember what it was called? The perpendicular distance, which is the title of our notes. So technically, this is a right angle right there, because those two segments have to be perpendicular. So I think if they're given an image where it's already drawn, I think that's why they're wanting to make a right triangle there. Luckily for you guys, because you guys are my advanced group, I don't do that for you. You guys don't get the right angle. So hopefully I don't get confused. We'll see. All right, try the next one without me. Let's just see how far we get. Let's just see how far we can do it, okay? Hopefully we at least graph the points, right, to make our lines. So this one's 0, 0. And then this one is -5, +5. So 1, 2, 3, 4, and then 5. All right, so... wrong one line. All right. We should also graph the point V, which is at 1, 5. So 1, +5. That's going to be point V. What's the name of our line? S. All right. Just make sure you label the S. And then what was the slope of the line given? What'd y'all get for the slope of the line? What was 5 minus 0 over -5 minus 0? -5 over 5, which is what? -1. Okay, this was your slope. So what was your perpendicular slope? 1. Again, the 1 is the only one where you can just do the opposite, like automatically just opposite number. All right, we graphed and labeled. From V, we need to go ahead and apply that 1. So technically it's 1 over 1. So what directions are we going? Up to the, if they're both positive, what directions are we going? Right? Or we can also go where? Down to the left. All right, so I'm going to go down to the left because I want to get to my line. So I'm going to go down 1 over 1. And what point did y'all hit? If I go down 1 over 1, all right, I'm going to go down 1 over 1. Down 1 over 1. Down 1 over 1. Did we all hit point -22? Okay. If you didn't, go ahead and graph it because you are going to need it, okay? All right, once you have it, you're going to go ahead and make the perpendicular segment there, right? This is the distance we're looking for. All right. Did anybody use the distance formula? I don't blame you if y'all didn't use it. To me, it's longer. How many did y'all mostly use the Pythagorean theorem? All right, let's just see how we did the Pythagorean theorem, all right? We're just going to rise and run. Rise and run it from these 2 points. So you're going to rise it, and you're going to run it. That's your little triangle right here. And the one that you're looking for is going to always be your C. What were your 2 measurements on the sides? 3 and 3. Both 3s? Okay. So we should have done a squared plus b squared equals c squared. So 3 plus 3 is, 3 squared plus 3 squared is 18. Good, because that's 9 plus 9. So then c is equal to the square root of 18. What is the square root of 18? It's about 4.2 would be your answer. Does anybody want me to show the distance one? No? Good. Okay, next page then. All right, looking at this one. So the difference between this one and the last one is this one, I gave you equations. We just have to figure out what the slope is from the equations, okay? So I'm going to start off with the easier one, which is this one here. It says they're parallel lines. So I should come out with the same equation for both of them. So how do I put this in slope-intercept form? What do I have to move over? The 3. Okay, so let's subtract the 3. We're left with y equals 2x minus 3. There's one equation. Okay. Our other equation is 4x minus 2. Y equals negative 4. What should I move over if I'm trying to get this into slope-intercept form? All right, let's subtract the 4x. That's negative 2y equals negative 4x minus 4. What do I have to do to everything? Divide everything by negative 2. Don't lose that negative. That negative's in front of that 2. All right, so y is equal to, what's our equation? 2x plus 2. Good. Do y'all agree that the slopes are the same? Yeah, what are the slopes? 2. So it says, are they parallel? We're going to say yes. What's a parallel slope? Remember, this is parallel. What's a parallel slope to this then? If my slope is 2, what would be a parallel slope to this? 2. Your slope would just be 2. Remember, that one's the same. What would your perpendicular slope be? Negative 1 over 2. Good. That's where, again, one of them has to be a fraction if they're not ones. The last one just says pick one random point from one line and apply the perpendicular slope. What is the perpendicular distance? Okay, so all we're going to do is we're going to graph these two. I want you to graph the negative 3 first, right? Negative 3. Apply a slope of 2 over 1. So we're going to graph negative 3 because that's our y-intercept. And from there, we're going to give it a slope of 2 over 1. So if it's 2 over 1, should I go up or down? Up 2 and then over to the right one. All right, so I'm going to go up 2 to the right one. Up 2 to the right one. Up 2 to the right one. Once you have about 3 or 4, you can go ahead and connect all of them and make your line. We're just graphing it, okay? Okay, we'll do the same thing with the other one. Which one should I graph first on the second equation? Right, we already did this one. This one's done. What should I do to graph on the second equation? What should I plot first? The 2. You're going to graph this 2 first, right? A positive 2. And then that one also has a slope of 2 over 1. So up 2 over 1, up 2 over 1, up 2 over 1. All right. So connect those. So the last step is telling you pick any point. It's asking you to pick any point, and it wants you to apply the perpendicular distance till you hit the second line. Okay, so once you have the 2 lines meeting, right, our slope was 2 over 1. What was the perpendicular slope then? What did we say it was? Negative 1 over 2. That's down to the right. So I'm going to pick this point here, And I'm going to go down 1 and then to the right 2. 1, 2. Do you see how I hit my line? You can pick any point. I'm going to pick this point here. Down 1, over 2. Down 1, over 2. Down 1, over 2. Did I hit the other line every time?
Yes.
Okay, that's how we know they're parallel, which is going to be the next piece. If it's the same all the way through any random points we pick, automatically they're parallel lines. So then, this one was asking for the distance. Guys, y'all made little baby triangles here without even knowing. Look, if I connect this one to this one, and you're finding this distance, you made a right triangle right there without even knowing. What's the length of one side? 1. What's the length of the bottom side? 2. So if I just want to find the distance here, and I'll do the work down here where it's supposed to be, we can do 1 squared plus 2 squared equals the distance squared. What's 1 times 1? 2 times 2? 4 plus 1? 5. Our distance is the square root of 5, and we can just leave it there. Y'all made all those little triangles without knowing. Okay, so the last piece is going to tie in with that. No matter what I picked, what point I picked, once I applied that perpendicular distance, I kept hitting that second line. And that should be true if they're parallel. So that's going to be the last piece. I'm not going to have y'all do practice 2 because I changed up the numbers and my numbers didn't work out the way I thought they were, so I just don't want to mess up your notes. All right, so last one's equidistant. Like I said, if they're parallel, they should be equidistant, equal distance all the way through. Now, this is an easy one. Like if I give you one like this on the test, I expect no one to get this wrong. You pick one point and you find your distance to the other point. Obviously, this one's perpendicular. So what's our distance there? 2. Pick any point. Is that 2? Okay, so that one checks off, that one checks off. And you pick any random points, right? Did they all check off to be 2? Yes. So is that one parallel?
Yes.
Yeah, even by looking at it, are they parallel? Yes, we can tell by kind of looking at it. We can confirm with the points though. All right, if they're not straight, you're going to do what we did earlier. You do the opposite slope and just make sure it hits every time. Okay? Do you know what I'm talking about? This one up here? Here where we did the opposite slope and we kept hitting it. That's all you would do, okay? Now the last one. Pick 2 points, any point. I'm going to pick this one here. This is a slope of 1, 2, 3, 4 over 1. 4 over 1. So 4 over 1 would be 1 over 4. So down 1 over 4. 1, 2, 3. Did it even hit on the fourth one? No, the perpendicular doesn't even work. Let's see. 1, 1, 2, 3, 4. Oh, it worked on that one. But did it work on the other one? Okay, so that one checked off, that one didn't. Even if you made up your own, right? This is 1 to 4. This one's 1 to 3. This one is 1 to 2. Were they all the same? Okay, so this is how you're proving that they're not parallel, right? Just looking at it. You can also prove it by the slopes. You can also look at it and see that they're going to eventually intersect. But if you're ever in doubt, again, the distance to the other line should always be the same.